Yes, you're welcome. Thank you for viewing our videos. You are still with me, your teacher of chemistry, and we have yet another new homologous cell we want to discuss. Previously, we've been discussing phenol. Now it's time for us to look at carbonyl compounds. What are carbonyl compounds? In this lesson, we are going to know what are the carbonyl compounds, what are the types of carbonyl compounds. We want also to know what are the names that we can give to these carbonyl compounds. And if possible, in this lesson, we shall also look at the isomerism in carbonyl compounds. So let's start straight away. In our introduction, what are carbonyl compounds? Now, carbonyl compounds are organic compounds with the carbonyl functional group, within the carbon chain. Now, what do we mean by the carbonyl functional group? The carbonyl functional group has the structure of a carbonyl functional group. You'll have a carbon atom to which oxygen is double bonded, and these bonds are open. Now, on one side of the carbonyl functional group, we could have either H or we can have alkyl groups. So, if we had H here and H this side, this gives us a certain compound and a carbonyl compound. But it's also possible that you may have alkyl groups on the other side. You could have HH, but you can as well have on either sides, you can have one side H, one side R. That's another compound. It is possible you can have both ends alkyl groups. We can even have on the carbonyl group, you can have one side a benzene ring, or you can have either sides a benzene ring this side and one side an alkyl group. You can even have both sides a benzene ring. So, in all these cases, these compounds are called carbonyl compounds. Why they are called carbonyl compounds? Because of the carbonyl functional group in them. The carbonyl functional group in these compounds is this structure. And we are saying on the carbon atom, because carbon atom must have 4 bonds, there are open 2 ends. And these open ends could be filled by either hydrogen atoms, alkyl groups, or aryl groups. So we come up with different varieties of these compounds. However, as we see the structures of these compounds, we can clearly look at 1 or 2 things happening here. We have these compounds where one side there is an H bonded directly to the carbonyl functional group. Compounds in which there is a hydrogen atom bonded to the carbon atom. That's one class. If you have a hydrogen atom directly bonded to the carbonyl functional group, that class of carbonyl compounds is different from these compounds where a chain of carbon atoms is bonded to the carbonyl functional group. There is no hydrogen there. There are two carbon chains. You can look at this type. There is a benzene ring this side, there is an alkyl group this side, and there is no hydrogen. And that is another class. Therefore, carbonyl compounds could be classed into two. We can say there are two classes of carbonyl compounds. Now, this is depending on the structure as we have said. Those in which there is hydrogen on the carbonyl carbon, and those in which the carbonyl carbon is sandwiched between two hydrocarbon chains. And so the first class, we call those compounds aldehydes. These compounds are called aldehydes. These compounds, these are compounds in which there is a hydrogen atom directly attached to the carbonyl carbon, directly attached to the carbonyl carbon. That is to say, if this is our carbon chain, there is a carbonyl functional group to which the H is attached. And therefore, this is the general formula of such compounds called the aldehydes. The general formula is RCH. Sometimes we simply do not expose the bonds and therefore write it as RCHO. The idea of starting with the H is to emphasize that there is a hydrogen atom attached on the carbonyl functional group, but also to distinguish them from the alcohols, rather than if we had written with O first, they would look so close. They would look so close to alcohols, yet they are not alcohol, because the alcohols are the ones with a hydroxyl group. So we write them this way to distinguish them from alcohols and also to show that on the carbon atom there is a hydrogen atom. Now, if these compounds are containing that hydrogen atom, that means these compounds can actually be oxidized. These compounds are reducing agents because they contain a hydrogen atom which can easily be removed. And removal of the hydrogen is oxidation. Compounds that undergo oxidation are good reducing agents. So those are called aldehydes. Let's look at examples of the aldehydes. Once there is a carbonyl functional group and there is H, this side of the carbonyl functional group, there could be R, and that R is equal to either a hydrogen atom. If not a hydrogen atom, it could be an alkyl group. If it's not an alkyl group, it could be an aryl group, a benzene ring. So, if it is a hydrogen atom this side, then we should have the simplest aldehyde. And that aldehyde exists. If it is an alkyl group, like the methyl, then we would have CH3 double bond H. But it could be possible for it to be a benzene ring. If it's a benzene ring, then we can have such a compound. So all possibilities are possible. And we know that the length of the alkyl group may depend on the number of carbon atoms. So you would have compounds as long as that. That is still an aldehyde. The difference now is that the hydrocarbon chain here has two carbon atoms. The hydrocarbon chain has one carbon atom, and that is what we call the aldehydes. How are the aldehydes named? How could we name the aldehydes now that we know about the presence of aldehydes? Aldehydes are named as compounds derived from alkanes. The nomenclature of aldehydes they are named as derivatives of alkanes by substituting the ending letter E of the alkane by letters Al, e.g. the first compound is C double bond H. This compound has one carbon atom. An alkane with one carbon atom would be called methane. And we are saying if this is not an alkane, but therefore an aldehyde, then we are going to remove letter E and substitute it with letters A, L. This one here, letters A, L. And we shall get the name methanol. The compound is called methanol. If there were two carbon atoms, you have the aldehyde group, and then there is an alkyl group this side, CH3. Now, the corresponding alkane would be called ethane. But we are substituting letter E with letters Al, and we shall get the name ethanol. And this is a good example. Now, if this was instead a benzene ring bonded to one carbon atom, this compound here has a benzene ring. Once the benzene ring is a side chain, then we call it a phenyl. So we have a phenyl group bonded to one carbon atom of the aldehyde. So the name would be phenyl methanol. Phenyl methanol. Although this compound will have other names like a benzaldehyde. These are other names. Benzaldehyde. Someone will call it phenyl dehyde. These are trivial names. However, as per IUPAC, we shall have it called phenyl methanol. These are other trivial names of that very compound. So this is how we are going to be naming the aldehydes. You simply substitute the ending letter E with letters A, L. Now, we can now look at the other class of the carbonyl compounds. And that class, we've seen that you do not have H. Instead, you have another alkyl group. So the carbonyl group is sandwiched between two hydrocarbon chains, and those compounds are called the ketones. Those compounds are called the ketones. These are carbonyl compounds. Carbonyl compounds in which the carbonyl functional group is between. The carbonyl functional group is between 2 hydrocarbon chains. These hydrocarbon chains could be alkyl groups, could be benzene rings. What are we saying? You have a carbonyl functional group, there is R, there is R. Where R, we are saying, could be an alkyl group, or it could be R may be equal to an aryl group. An example, if you had a methyl group this side, and a methyl group the other side, we could have a methyl group one side, but then the other side is an ethyl group. They could as well be different. It is possible to have one side a benzene ring, but another side there is an alkyl group. In these cases, there is no hydrogen atom on the carbonyl functional group. So these compounds cannot be oxidized because there is no hydrogen to remove. These compounds are not reducing agents. They cannot be oxidized, and that's a huge difference from the aldehydes. It is even possible to have 2 benzene rings sandwiching the carbonyl functional group. Now, how could we name these compounds? The nomenclature of the ketones, because now we have understood what the ketones are. The ketones, how could we name them? Nomenclature. They are named by substituting letter E, of the corresponding alkane with letters ONE, with letters ONE. For carbonyl compounds with more than 2 or with more than 4 carbon atoms, with more than 4 carbon atoms, the position of the carbonyl functional group must be specified. Let's look at some examples. The first one, this compound. This compound having 3 carbon atoms means it comes from an alkane called propane. But we are saying we are going to substitute letter E of the corresponding alkane with letters ONE, and the compound would be called propanone. The same would happen if there were 4 carbon atoms. This one should be butane, but we are substituting letter E of the corresponding alkane with letters ONE, and the name is butanone. And one more example, what if they were 5? If they were 5, this compound would be called pentane if it was an alkane. However, it is also a ketone, so it should be named pentanone. However, you have to locate the position of the functional group. And within the carbon chain, because the carbon atoms are more than 4, within the carbon chain, this is supposed to be given the lowest number possible. So if we name A, actually these ones are 6. This is supposed to be xn. So we are removing letter E and locate that on position 3 there is anione. So this is hexane 3-on, and that's the name of this ketone. And in this lesson too, so we've looked at the nomenclature of the carbonyl compounds. We've looked at the general introduction about these compounds. So in the next lesson, we shall be looking at many other things about the carbonyl compound. Thank you, don't miss.